Hello everyone, welcome to my channel Chemical Engineering Lab. In this lecture, we are going to discuss about the heater. Water is flowing in a heater and water is heated in the heater from 30 degrees centigrade to 80 degrees centigrade at constant pressure, 1 atmospheric pressure. The molecular rate of water entering to the heater and leaving from the heater is constant, which is 100 kg mole per hour. So what is the heater duty? So first of all, we will come to the Aspen Hysys. Click on add the component. So add water, click on add, then come to the click on add, then come to the fluid package, click on add fluid package. I am using NRTL, so NRTL, click on NRTL, so it is okay. Then come to the simulation. This is the material stream, this is the energy stream. So this is third material stream, this is the material stream number 1. So click on it. So this is name, by default its name is 1, so I am using cold water. Cold water is at 30 degrees centigrade and 1 atmospheric pressure. 1 atmospheric pressure is equal to 101.3 kilopascal. The molar flow rate is 100 kg mole per hour. So this is the material. Now it shows that unknown composition. Come to the composition and add the composition of water. So pure water, the composition of pure water is by default 1 mole fraction. So click on OK. That is okay. It is fully specified. Now come to the this is okay. Now then come to the another stream, the outlet stream. This is the hot stream. So hot stream, which is hot water. So hot water. The hot water is at 80 degrees centigrade and 1 atmospheric pressure. 1 atmospheric pressure, and the molar flow rate is 100 kg mole per hour. So it shows the unknown composition. Come to the composition, unknown composition. Composition of the product water or the hot water is also 1 because pure water is entering and pure water is leaving. So it's okay. So it is okay. Now come to the heater. This is the heater. Click on it, drag it. Now double click on the heater. By default its name is E100. You can change it. If you just leave it. Come to the inlet, add the inlet, cold water to the heater and the hot water outlet from the heater. Now we require energy stream. So give its name, heat of the energy added to the heater. So it's huge. So it is okay. It is okay. Now this is the heater. The cold water. So now the heat duty. Now how much heat is added to the heater? So this is the pressure drop is 0. Delta T is 50 degree. Change in temperature delta T. Heat duty is 3.795 multiplied by 10⁵ kilojoule per hour. So click on heater and come to the worksheet. So this is the heat duty which we added to the heater to increase the temperature of liquid water. So this is the performance plot table. This is the table. This is the table. Temperature, pressure is constant, enthalpy and the heat. So the heat is this 1 kilojoule per hour. And the vapor pressure is 0. Come to the plot. This plot shows the temperature versus pressure. So constant pressure versus. You can change heat flow versus temperature. So temperature versus heat flow. And if you come to this is 3.74 multiplied by 10⁵ 3.77 multiplied by 10⁵ kilojoule per hour. So this is all about the heater. How much heat is added to the heater? You can also add work table, like you can add material stream. So planet, you can add energy stream, like composition, select composition 1 You can also add the energy stream. Click on energy stream, click on select. So energy stream is the energy. 3.79 button for 7 kilojoule per hour energy is added to this heater to increase the temperature of cold water from 30 degrees centigrade to 80 degrees centigrade at constant pressure, which have same water flow rate. And this is all about the mass flow rate. These are calculated by Aspen Hysys. So thank you very much for your attention. If you are new to the channel, please like and subscribe.